morning guys. Today we are going to perform another experiment in process dynamics and control lab. So that is flow control training. Here we will study how the flow controls when we apply a different types of controllers like P controller, I controller, D controller, PI controller, PD controller and PID controller. So here first what we will do in this experiment, first we will study the open loop system and then we will study the proportional controller, proportional integral controller and proportional derivative controller, and also we will study proportional integral derivative controller, and finally we will see the stability analysis and we will perform the border plot. Okay, so before we get into the experiment, let us see the parts in the equipment. So first I will show the front view. So in front view, basically in this equipment we have a 6 valves. 6 valves. This is the valve 2 rotameter which we will use to control the flow, and we have a valve 3 which we will use to make a disturbance in the process, and valve 4 and valve 5 which are connected to the water tank, and also you have a control panel which you have to switch on where you can set the set point, and it is the rotameter which we will use to reduce or increase the pressure. To regulate the pressure we are use this rotameter, and this is the main switch which is when you switch on it the water pump will be turned on. Okay, and also here you have a control valve. So the clear action in the control valve you can check it out here, and you have a IP converter which will help you to convert the electrical signal into the pneumatic signal, and that pneumatic signal will enter into the system where in the system the SCADA software will be installed, and those signals will be recognized by the computer and you can see the result over it. Okay, now we will see the back view. So in the back view you can see it, the whole process. So this is your tank, water tank, that is the process tank we will call it here, and which have a vent valve, that is a V6, and V1 is the valve through which the pressure will enter. So how you will create the pressure here? You will use the compressor. Okay, so this is the back view. Now we will start the experiment. So before you start the experiment, you have to check it out all the valves. We have 6 valves, right? All the valves are closed or not. So if it is open, you have to close all the valves, and then first you have to turn on the motor. I have turned on the motor, and now you have to open the rotameter completely. So I have opened the rotameter completely, and then you have to open the valve 1 through which the pressure enters. So I will slightly open the valve 1. I open the valve 1. So the pressure is entering over here. So now you have to regulate the pressure here. So I will regulate the pressure here. So now some pressure I have given to the system. You can observe here the rotameter starts oscillating. Okay, and then what is the use of V3? I told you we will use this V3 to give some fluctuations in the process. So now it is off. If you open on it, the fluctuations will start, and again the fluctuation are almost start. It will take time to get the fluctuation. Earlier the fluctuation was very high. If you observe, the earlier was the fluctuation was very high. When I am opening the valve V3, the fluctuation will decrease. So basically we will use this valve 3 to make a fluctuation, to make a changes in the flow. Done. And then valve 4 and valve 5, which are like a inlet and outlet of the water. So I am just opening these 2 valves. Both of the valves are completely open. Okay. So now you have a control panel here. You can set the set point at a required value. So what I am doing, I am increasing the set point to 50 and click on the set. So the set point was fixed to 50. Now the fluctuations were observing here. And one more thing, this is your control valve. If you observe it, this particular disc, it will open and close. This is like the system now running in a on and off mode. It will completely open or completely close. When it is completely open, the pressure will be released. When it is closed, the pressure will maintain in the process. Clear? So now we will see, we have set up the complete system. Now we will operate in the computer where the SCADA software is installed. Okay, let us see. So now we will operate the whole system which I have shown earlier by using the PC. So this is a software which is already installed here. So first you have to click on the login button. Okay, it's getting loaded, and then click on view diagram. So here the whole process you can see it here. As I explained for the temperature control trainer, you can see the whole process here. The pump which is connected to the sample tank or the sump tank, that we will call it as a process. Then that take the input from the controller output, and you have IP converter which you help to the convert the electrical signal into the pneumatic signals. Okay, observe it properly, and now click on the back, and then you can get into a simulation tab. So click on the simulation. So the main process is appeared here. So what you have to do now, you have to click on the start button. You have to click on the start button. So now the process is on. As I told you, first we are going to study the open loop system. So how you will study the open loop system? You have to keep the process in a manual mode. So I have clicked on the manual mode. Let it be. Let us wait until it reaches to the steady state. And meantime, I have to open loop means that is a short of a open loop system. Okay, like the proportional controller. So I will remove. I will do it as a 0. I will make the value 0 here. So it is a P mode now. So let me convert into the manual mode. So it is the manual mode, and you have to keep the set point to 100. You have to keep the set point to 100, and let us wait until it reaches the steady state. Once the process reaches the steady state, as we did in the temperature control trainer, we will decrease the set point from the 100 to 90, and we will wait for some time until the process reaches the steady state. And once the process reaches the steady state, then we will move on to we will change the set point from 100 to 90, 90 to 80, 80 to 70, like that we will go till 0. Okay. So let the process reach the steady state. You can observe the changes in the set point, process value and output. Here is the set point, red color one, blue color one is the process value, and green color one is the output value. And the graphs which are related to it you can observe here. The set point is 100, so the red line is straight line, and the process value is increasing now. Okay, you can see the value 92.5, 92.6 like that, and the output value which is decreasing. That means the system is coming to the steady state. So we have to wait until the process reaches to the steady state. Then we will note down the set point value and the process value. After that we will draw a graph between set point value and process value, and we will see the step change in the process. Let it come to the steady state, then we will change the set point value. The process is almost reached the steady state. We will wait for one more 30 more seconds. So the process almost reached the steady state. Here you can see the set point is 100. At set point is 100, the process value is 93 and the output value is 64. So now I am changing the set point from 100 to 90. So you can observe the change in the process value as well as output value. The process value is decreasing. You can observe in the blue line. Okay, in the graph you can observe the blue line, it is decreasing. And when I have changed the set point from 100 to 90, that's a step change you can observe here, 100 to 90. And then due to the change in the set point, there is a sudden fluctuation in the output value. So that's why it is decreased, and after that the output value is coming to the steady state. Okay, so we have to wait until the process reaches to the steady state, and then we will note down the set point value and the process value, and after that we will change the set point to the 90 to 80. Okay. So now the process reaches the steady state, and at the set point of 90 the process value is 81 and output value is 68. So now what I will do, I will decrease the set point from 90 to 80. So you can observe the fluctuation in the process value as well as the output value. So the process value will slowly decreases, and the set point in the output value there will be a sudden fluctuation, and then after that it will come to the constant. Okay, so we will wait until the process reaches the steady state. Let us see what the process value we will get at the set point of 80. Now the process reaches the steady state, and where at the set point of 80 the process value we got it as 71 and the output value is constant, that is 68. Like that we will go till 0, the set point 0. Okay, you can make this, we have to, after this we will make the set point to 70. Once it reaches the steady state, you will note down the values, and again then you will change it to the 60. Like that you will go till 0. Okay, I hope you understood how to perform the open loop system. So at a set point of 10, the process value completely become 1 and the output value is constant. So if you change the set point from 10 to 0, that means if you make the set point as 0, then the output value become half. Only 50% is the output you will get, as well as the process value will become 0. Okay. So like this we will perform for the open loop system. So now let us see if we will apply a proportional controller to the process to find out the error, then what happens. So for that you have to convert into the auto mode to manual, and then you have to give at the KC value as much as high it's possible. So here I am giving the KC value as 25. Okay, I am changing it to the manual to auto mode. Okay, so once you change it from manual to auto mode, we will click on the function generator, and then you can see the fluctuation in the output. And what we will observe here is, when we are using a proportional controller, and we will change the KC value, and we will see whether there is a change or the fluctuation in the set point process value as well as the output value. Okay, so for making it clear, I will make the amplitude as 30. So the difference you can see for more time. Until you will observe a fluctuation in this value, you have to change in the set value, process value and output value, you have to change the KC value, proportional derivative. So when it is 25, there is no fluctuation in the process value and output value, but there is some fluctuation in the set point. Now what I will do, I will change the proportional gain value to the other value. How we will change? Initially I kept it as 25. In that half of the value I will change. That means I will give the 12.5 here instead of 25, and I will wait and I will check it out whether there is a fluctuation in it or not. I think there is no fluctuation. You can observe it properly. right? So I will change the Kc value from 12.5 to half of it. 12.5 half, it is around 6.5 or 6.7 you can give. So I will give 6.7. So we will see whether is there any fluctuation or not. You can observe a good fluctuation in the set point, but there is no change in the process value and the output value. Now 6.7 to half of it. 3 point. I am changing this value 6.7 to half of it, like you can say 3.25. 3.25. Let us see we are getting any fluctuation in it or not. So there is no fluctuation in the process value and output value. We will make it to half, that is 1.5. Then again let us change it to the 1.5 to 0.75. So now we are going to apply a P mode here. So how you can apply the P mode? Just keep the P value, the Kc value as much as big, that is 25 I am giving. And then you have to click on the auto generator. So I have click on the auto generator. So I have kept the proportional gain value as 25, and you can observe the fluctuation in the process, right? How you can observe the fluctuation? You can see the PV value is fluctuating, output set value is fluctuating, and output value is fluctuating. So we will try to minimize the fluctuation. Not minimize the fluctuation, like the smooth curves we will try to bring by changing the value of Kc value, that is from 25 to 12.5 I am doing, like the half of the value you have to decrease. When you are performing the experiment, you have to decrease the value half of the initial value. Okay, so I have changed it and I have already switched on the function generator. So the curve, we are trying to make that curve as much smooth as it can. Okay. So there is an error. If you are not getting a proper smooth curve, that means there is an error in the process. Obviously each process will have an error. To minimize that error only, we are adding the controllers like proportional controller, integral controller, derivative controller, right? So I will decrease the value from 12.5 to half of it, that is around, we can say 7. Not even 7, 6.7, 6.25. It is like sort of trial and error based process. Okay. So you can observe here the smoothness may goes on increase. Okay. Observe the blue line and the green line, whether you are getting a smooth curve or not. I will make it more smaller value. We will go to the 3 now. We will see whether we are getting a smooth curve or not. So it is getting smoother. If you can observe here the curve and here the curve, the smoothness is increased. It is like little bit a sharp one, but here you are getting a somewhat a good sinusoidal curve, right? So like that way that you can go to the small number also. You can go to the small number also. Let us see we are getting the small number or not. 1 point at the small number. 1.5 I will make. the Kc value. I will make it to 1.5. You will observe how the curve is changing. The smoothness has increased now, if you can observe, but the magnitude is decreased, but smoothness is increased. The peak magnitude is decreased. So what you will do is simply click on the log on button. Then it will ask you to save the data. So what I will do on the desktop, I will save the data as a P mode, since it is a P mode, since it is a P controller, P mode. So for 1 minute almost, like the two sinusoidal curves. This is the one curve and second curve. So that is enough data to do the calculations. So here what you will do, the difference between the curve, upper limit of the curves, both the curves you will take, and the data you will use for doing the calculations. Okay, no need to record more amount of data. So yeah, the data is enough to do the calculations. Now I will log off, and then what we will do, there is a error. If you see the fluctuation in it, you are not getting a proper curves, you are not getting a proper sinusoidal curves. That means there is an error in the process. So to minimize that error, to the Kc value, that means to the proportional controller, I am adding an integral controller. How you will add the integral controller? You will give the Ti value, the integral time value, to the system. So I will give as much as high. I will give the 10 value 10 integral controller, and we will observe the fluctuation in the process, as well as we will check the smoothness of the curve. That smoothness of curve means the error of the process. So let us observe. If you are not getting a smooth curves of both the process value and the output value, as well as set point value, then we will decrease the integral time value. Here also you have to decrease the value half of the initial value. If it is 10, then we will decrease to 5. I think the value which I have given is almost better value I have given, because you are getting a smooth curve here. So let us see, let the system come to the steady state. Yes, you are getting a almost smooth curve. Yes, there is a fluctuation here. You can see the green color one, green color line. There is a fluctuation, like there is a error in the process. You can start record the data from here. Simply log off, log on, and I am saving it here as PI controller. PI control, and click on OK button. So the data start recording, and you will simply take 2 to 3 sinusoidal curve. That is enough to do the calculations. Somewhat smooth curve you are getting as compared to the proportional controller. When you are using the integral controller, you are getting somewhat a smooth curves. That means the error is minimizing. So the data which I have recorded, that is enough for the calculations. I will log off the system, and then we will check it out. Instead of integral controller, I will add a derivative controller to the proportional controller, and I will check how the output is changing. Okay, so to the proportional controller I am adding a derivative controller. Again I will add a 15 value 15, the derivative controller. So now the mode is also converted into PD mode, and you can observe the curves which you are getting. So let the system come to the steady state, and if you are getting a smooth curves, then that means the error is minimized, so that we can finalize the derivative data. So somewhat smooth curves are you are getting, but here it is not a the green one is the sinusoidal, not a sinusoidal curve. There is, you can make it a more smooth. Again here also you will decrease to half of the initial value, that means 7.5. So I am not getting that much clear sinusoidal curves. So I will decrease the value to 3.5, half of the initial value. Let us see. Hopefully we will get a smooth curve as compared to the earlier. Yep, somewhat clear curves you are getting. Here you can see there is a fluctuation in it, but here you are not getting any fluctuation, you are getting a smooth curve. So I will start record the data. Save in the desktop. It is a PD controller. PD controller I am saving it. So I will record the data. So for 2 to 3 curves, that is enough, that data is enough for doing the calculations. So I will only note it down the data only for 2 to 3 curves. Still you can see there are fluctuations, that means there is an error in it. So that error we will minimize by adding a integral controller to the PD controller. So hopefully we can minimize the data, minimize the error. So I will log off, and now I will give to the PD system I am adding the integral part. So that what happens? The smoothness of the curve may increase. So we are not getting a smooth curve, then you can minimize the value, the integral value, so that we can bring a smooth curve to the process. I will make it 5. So here we are getting somewhat smooth curves. So let us see, let us wait until we will reach the smooth curves. We will change integral value to the bigger number. We will check it out whether we are getting a good value or not. You are getting a smooth curve somewhat, so you can start the log button and you can start recording the data. We are recording the data now. Only for 2 curves I am recording the data. So this is the one curve, I will note it down, and then the second curve which is going to complete now. So this data is enough for the calculations. So I will turn off. Better to take one more reading. Yes, I will turn it off. So the curve which you are getting here, when you are adding a PID, the 3 controllers together, then you are getting a better result, and the error is almost minimized. Somewhere you are getting an error, but the most of the times you are getting a proper results. And now if you want to do the stability analysis, simply what we will do, you can change the amplitude, you can change the time period. If you change the amplitude from 30 to, for example, 50, then you can observe amplitude is increased. That means the height of the peak will be increases. The height of the peak will be increases. And if you increase the time period from 10 to 30, then what happens? the width of the curve will be increased. See, from here the width is like this. When I keep it to the 30 seconds, then the width is increases more. You can observe here also the width is increased. Earlier the width is like this, now the width is increased to too much. Okay, so like that you can do the stability studies also. So I hope you understood how you can perform the flow control trainer experiment. So we will meet in the next video with the level control trainer. Thank you.